So moving on to example 1. If this circle is circumscribed around the triangle, then I know the length from P to all of the vertices is going to be equidistant. So I could say that PG is congruent to PL, which is congruent to PH. So again, P is equidistant from each of the vertices of the triangle. All right, so example 2. What is the center of the circle that you can circumscribe about the triangle with vertices 2, 6? So 2, 6, I go right 2, up 6. 2, 0, so right 2, and then 10, 0, so just right 10. So I'd have this triangle right here. If I wanted to circumscribe a circle around this triangle, so this was B, that was A, that's C. What would be the center of that circle? Well, if I'm trying to find the center, based on this, that would be the circumcenter, because the circle circumscribed around a triangle. The center of that is called the circumcenter. For the circumcenter, we use perpendicular bisectors. So I'm going to have to find the I just need 2 perpendicular bisectors of 2 of the sides. The easiest ones would be the vertical height and the horizontal one, because then I can just count. Because the bisector, remember, has to be in the midpoint. So if I want to find the midpoint between A and B, well, A and B is 6. So 1, 2, 3, 4, 5, 6. So halfway would be right there at 3. That's the midpoint. The midpoint of BC, so B goes from 2 to 10, so that would be 1, 2, 3, 4, 5, 6, 7, 8. So I go half that, 1, 2, 3, 4. That's the midpoint of BC. So wherever those two intersect, the perpendicular bisectors, so that'll be right here at this point. So remember, perpendicular means they form 90-degree angles. So this point right here would be the circumcenter, or the center of that circle. So that is at 6, 3. So 6, 3 be your answer. Example 3. So a landscaper wants to build a goldfish pond that is equidistant from the gazebo, the rose garden, and the bench. How should the landscaper determine where to build the goldfish pond? Well, if it's equidistant from each of these points,